Hello, welcome to the next video. We're continuing on with moving through things that will be in the numeracy assessment. So what we're looking at next is scale reading. I'm hoping this is something you're familiar with and are probably capable of doing, and doing yourself anyway, if not on a daily basis, then fairly often. But we just need to go over it, make sure we're comfortable with it, because it will be asked about, okay? And by scale reading, we mean seeing something like this and being able to tell what is meant by what we're pointing to. So it could be in a thermometer, being able to read off what temperature is being told by the thermometer, looking at the speedometer in a car, being able to tell the speed, looking at a scale on a weight or something like that. So there's a lot of different uses for this, and we just need to be very comfortable with it. And it is fairly simple, and it all comes down really to sort of 2 steps to being able to work it out. So let's start with a nice easy scale or number line, something like that we'll be able to do. So at this end I've got 1, at this end I've got 10, and what I'm going to try and do nice and somewhat evenly is say that I've got 1, 2, 3. I've done this so bad. Sorry, had to pause and redo that since I drew it terribly. Your scales only work, and we can only read them, if each of the little divisions, each of the little bits it's split up into, are all the same size, okay? And they always will be on a scale you're looking at. So if we look at this one here, it starts at 1, and it goes up to 10, and say this is on a thermometer or something, and it was filled in all the way up to here, and I want to know what the reading is for this red line. Well, you know what to do, don't you? Okay, we see how many divisions there are. So if we look here and count how many actual bits we've got there's 1 here, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we've got 10 gaps between 1 and 10. And so we can work out how big each of those gaps must be. If we've got 10 gaps going from 1 to 10, well, each gap must represent 1. So by the time we get to each little line here, each division, it's gone up by 1. So to go from here to here, well, we've gone 1, 2, 3, 4, 6. So this is reading 6 here. Now, we know how to do that when it's something nice and simple like this and something we're used to. It's a little bit trickier if it's not so obvious what it's split up into. So say, for example, we had one that started here, went up, and say it went from 5 to 9, okay? And it's split into up like this, and we're saying I want to know what this one here is equal to. If I popped something on this and it was a scale or something and it pointed here, what does that mean? Okay, and so there's 2 steps we need to do. So our first step is to work out how much is represented, how much there is between the start of a scale and the end. Okay, so it's going how much is there from 5 to 9. So first step is how much does the scale cover? This one, fairly simple. We don't need the calculator or anything. If it starts at 5 and it goes up to 9, well, that's covering a total of 4, isn't it? From 5 to 9. So how much does this one cover? Well, it covers 4. Okay. Next step, I'm actually going to split this up into a few more steps. So next step is how many divisions do we have? How many little gaps are there? So by divisions I mean how many spaces are there between the lines. So how many divisions? Again, let's count them, okay? We've got 1, 2, 3, 4, 5, 6, 7, 8. So there are 8 divisions there. And be very careful We're counting the gaps between them, not the lines. It's the gaps between we count, not the lines themselves. And so, we know it's going from 5 to 9, and we know it's split up into 8 little bits. So we need to work out how much each bit represents. So that's our next step. Sorry, I'm just going to move all this up out of the way a little bit. So, how much does each division represent? Again, reading scales like this is something you can probably do. We just need to know the maths behind it. So if we get a really hard example that we can't see straight off, we can do it. So how are we going to work out how much each division represents? Well, we do a simple sum. We take how much it covers, so 4, and we divide that by the number of divisions. So 4 divided by 8. You could use your calculator for this if you want to, but that gives you 0.5. So, we know it covers a total of 4. It's split up into 8 parts. So if we do the 4 divided by the 8, that tells us each part is 0.5. So the last step then is just to count up. We know each line here means 0.5. So what does it mean when we get to here? Well, let's have a look. We've got 5 here, then this is going to be with a 0.5 added on. So this one here, well, that's 5.5. If we add another 0.5 on, that gives us 6. If we add another 0.5 on, that gives us 6.5. If we add another 0.5 on, that gives us 7. Another 0.5 on gives us 7.5. And another 0.5 on gives us 8. So that means here, that is 8, that is pointing to. So that's the process for doing these. And it is something you'll be doing yourself in your head, possibly without even realising it. So let's have a look at some examples then. You'll see I've got a couple of different ones here. I've got 2 going horizontal like this. I've got one like you might see on the side of a measuring cylinder or a jug, and one you might see on weighing scales or a speedometer, something like that. But they can all be read in the exact same way. So let's start here with this first one. The first number I need is how much is covered from the start to the end. Well, it starts at 2 and goes up to 3. So it covers 1. There's 1 between the start and the end. And I want to divide that by how many divisions there are. Well, I've got 1 division, 2 divisions, 3 and 4. So divide by 4, I've got 4 divisions. Again, we can use a calculator. It will tell us that each division equals 0.25. So then what we do is we add on 0.25 from where we start for every division there is going up. So I'm going to show all the steps of this. I might not for all the others. So if I go here, this is going to give me 2.25 because I've added on 0.25. Again, you can use your calculator if you need to. So this one then is going to give me 2.5. And then to here, this one will give me 2.75. And that's my answer. Let's look at the next one. First number we need is how much is covered from the start to the end. Well, it goes from 10 to 15. So the amount it covers is 5. There's 5 between the start and the end. Then I want to divide it by the number of divisions. Now these aren't all evenly spaced because I'm not very good at drawing these out, but pretend they are. So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You don't need to number all of these on like that. I'm just doing it to make it clear as I go along. You can just count them. So I'm going to do 5 divided by 10. Well, again, like one of the ones we did before, that gives us 0.5. So for each little mark, it goes up 0.5. So let's have a look what that gives us. So that's going to be 10 to here is 10.5. Again, you don't need to mark every one of them down. Just make sure you don't get lost and you keep track of it. Here, that's going to be 11. Then here is going to be 11.5. And here is going to be 12. So that's our answer there. This is something you might see on a ruler, something like this. Here now, like I said, measuring cylinder. So what we could do actually here, to make this a bit more realistic, we could put units on. We could say this is measuring millilitres. And if it's got units on it, your answer needs to have those same units. But the process is exactly the same. First we need to know how much it's covering. So how much is there between the start and the end? Well, it starts at 75, it goes all the way up to 100. So 100 take away 75 is 25. That's how much there is from the start to the end. Then we divide it by the number of divisions. Well, we've got 1, 2, 3, 4, 5 divisions. So 25 divided by 5 equals 5. We're going to put mils because that's the units of this. So each little mark on here is going up 5 mils. So let's do that. 75 to here is 80, to here is 85, to here is 90 mils. This last one, I said it looked like a bit like a speedometer, so let's make it be in miles per hour. So, again, our first number is how much it's covered. What's the difference between the start and the end? So it goes from 0 to 48. Well, that's nice and easy. The difference is 48 between them. And then we need to know how many divisions there are. I'm not going to write the numbers down this time because they won't fit, but I'll still mark it and keep a count. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So we've got 16. 48 divided by 16, well, that equals 3. So each little line is represented 3 miles per hour. So let's just go through them and count. If I start at 0, that means here I'm at 3, 6, 9, 12, 15, 18, 21. See how I'm going up in threes all the time? 24, 27, and 30 miles per hour. So, if you see a hard scale to read that you can't just look at immediately and work it out, that's the maths behind it. So you have that strategy now as well. If, and I say if, when, because there definitely will be, you get a question like this. Hopefully that was understandable. If not, you know how to get in touch. Thanks for watching.